So we will be discussing the equations of parallel and perpendicular lines. So if lines are parallel, they have the same slope. So say for example, I have 2/3 x plus 3 and y equals 2/3 x minus 3. Okay, so you see here the slope of these two lines are both 2/3. Okay, and this should not be the same, otherwise they become coinciding lines. They have to be different. Okay, so let's graph them to prove that these are really parallel lines. So your slope intercept is 3, so it passes through 0, 3. So that's the point out there. And then your rise is 2, so you go up by 2 and then run by 3. Okay, so 2 points determine a line, so this is your line. That's the first line we have. Now we'll go to the next one. The slope intercept is negative 3. Okay, so it passes through 0, negative 3, and then the rise is 2 and the run is 3. So as you can see, the lines are parallel. Okay, now if two lines are perpendicular, then they are negative reciprocals in slope. For example, I have y equals 3/4 x minus 1, and the other one is y is negative 4/3 x plus 2. Okay, so negative reciprocal means the fraction is flipped and the signs are different. So let's graph and prove that they are really perpendicular with each other, meaning forming 90 degrees with their intersection. So let's start with this. So our uh, y-intercept is negative 1, so you go up by 3, 1, 2, 3, and then to the right by 4. Okay, so that's our line out here. And this one, our y-intercept is positive 2. So we're talking about that. And the rise is negative 4. So we have to go down by 4. 1, 2, 3, 4. And then go to the right by 3. 1, 2, 3. Okay, so as you can see, okay, the lines will be perpendicular with each other. Okay, now in the case of perpendicular lines, it doesn't matter whether you have different or the same y-intercept. You can also have plus 2 in here, so it's fine. All right, so we are now ready to form equations of parallel and perpendicular lines. Okay, so let's say I have a line 3x or y equals 3/4 x minus 5, and it's supposed to be parallel to a certain line whose y-intercept is negative 4. Okay, so if we're going to draw our line, okay, so in analytic geometry, it's always best to visualize what you are doing. So it's best to graph them first, but of course, if you know the algebraic rule, it's fine. So we'll draw first this line, negative 5. So you have 1, 2, 3, 4, 5. Okay, and then go up by 3, and then go to the right by 4. So this is the line that we are talking about. Now we would like to find an equation of a line that's parallel to this line, and y-intercept is negative 4. So the y-intercept is negative 4, so we are looking for this line. Okay, because it's supposed to be parallel to that line. Okay, now we know already that the slopes of parallel lines are the same. So the slope of this is 3/4. Therefore, the slope of the second line is also 3/4. And because we have a slope and a y-intercept, we can form the equation by using y equals mx plus b. Okay, so I'm going to use this space. I don't have enough space. So therefore, our equation is y equals 3/4 x minus 4. Okay, that's the equation we are looking for, and they are parallel. So this one is a slope-intercept form, and of course we can express this in the general form or standard form by using ax plus by equals c as our form. So we multiply first by 4, that's the LCD. So this becomes 4y equals 3x minus 16. And because you would like it to be equal to a constant, you have here transpose x, and it gives you that. And of course, in analytic geometry, we always want x to be positive. So we will multiply the whole thing by negative 1 to make x positive. So our final form of the standard form is this. you can always check the answer whether it's correct or not. Now, this line is passing through 0, -4. So your x is 0 and y is -4. So if it passes through the line, it will satisfy your equation. So that will be 3 times 0 is 0, -4 times -4 is 16, and 16 is equal to 16. That's how to check whether your answer is correct or not. Okay, now we'll go to the next example. Now this time I'm going to make use of perpendicular lines. So I have a line 5x plus 2y equals, let's say, 10. All right, and there is a line that's perpendicular to it, and the x-intercept is, let's say, -2. Okay, so we need the slope of this, but it's not explicitly given, so we have to put this in slope-intercept form. So you have 2y equals -5x plus 10. By transposing 5x, it becomes negative, and then we will divide by 2. Okay, so the equation that we are looking for to find the slope is y equals -5 over 2x plus 5. Okay, so therefore, our slope is -5 over 2. And that also means that our line that's perpendicular to it has a slope that's equivalent to 2 over 5. Okay, because they're supposed to be negative reciprocals. Okay, now let's see if what our problem mean. Okay, so your line first is -5 over 2x plus 5. So 1, 2, 3, 4, 5. Okay, and then you go down by 5 and go to the right by 2. So this is the line that we are looking for, and we're trying to find the equation whose x-intercept is -2. Okay, and then from that you go up by 2 and then go to the right by 5. Okay, so these are supposed to be perpendicular with each other. Okay, now we are trying to find the equation of this line. And since a equals -2 is actually a point, okay, because this is an x-intercept, that means your y is 0. So therefore, the equation that we are looking for is the slope is y equals 2 over 5, okay, and it passes through the point -2, 0. Okay, so therefore, we can make use of the point slope form of the equation of a line, which is y minus y1 equals mx minus x1. And we plug in the values, that's y minus 0 is equal to 2 over 5 x plus 2. Okay, or you can do x minus -2. So I would advise that whenever you plug in negative formulas, when you plug in the value, change the sign. So from -2 becomes positive. Of course, you can always take the long path, x minus -2, but negative times negative is positive. Okay, so this is 0, by the way, so this doesn't count. We can multiply the whole equation by 5 because that's the LCD. So 5y equals, I'll do the shortcut, I don't have enough space. So we will cancel 5 and we will distribute 2. That's 2x plus 4. Okay? And so we would like to put this in standard form. So you have now -2x plus 5y equals 4. Then, of course, we always want x to be positive, so we will multiply by -1. And so our equation is 2x minus 5y is equal to -4. Of course, you can always check your answer. Remember that in a equals -2, your y is 0, so this doesn't count, and 2 times -2 is -4. So therefore, the equation of the line that we are looking for is 2x minus 5y equals -4. Now remember, okay, remember that in analytic geometry, you are recommended to label your graph like what I'm doing. And as you can see, if you have the standard form of our perpendicular lines, you would notice that the numerical coefficients of x and y are flipped and the signs are different. It could be that these are both positive, the values of x are positive and negative. Okay, it doesn't have to be y, but in standard form, okay, x should always be positive. In the case of parallel lines, you would see that your x and y are identical with each other. So this is how we form equations of parallel and perpendicular lines.